Hi everybody, welcome back. This is Unit 4, Lesson 10. And we're going to talk about two other groups on the periodic table that you have to know more than, just general trends about. And that the first one of those is group 17, which is highlighted here in red. That's group 17. And then right next to it, we'll also be talking about group 18 today. So you need to know their name and then some specific things about them. The group 17 elements, fluorine, chlorine, bromine, iodine, are known as the halogens. They are group 17, and if you recall, the last number of the group is how many valence electrons they have. So they have 7 in their outer shell already. And if you recall, happiness in your outer shell is 8. So in order for fluorine or chlorine or bromine or iodine to become stable, if they have 7 in their outer shell, they just need to gain 1 more to be stable. And if you gain 1 electron, since electrons are negative, you will have a charge of -1 when you are an ion. They are excellent because they are nonmetals at attracting electrons. And what that means is that it's very hard to take away their electrons. So they have high ionization energies. It requires a lot of energy to remove their valence electrons. And they have high electronegativities. They're very attractive. They attract others' electrons well. These are the most reactive nonmetals on the whole periodic table. And the reactivity of nonmetals is opposite the reactivity of metals. Their reactivity decreases down a group. This is a very important point, okay? So with metals, we said the biggest metals are the most reactive. With nonmetals, it's opposite. The smallest nonmetals are the most reactive. Okay? These are so reactive, all of them in group 17, that you, like group 1 and like group 2, you cannot find them in nature in their elemental state as pure elements. They only exist as stable compounds. And they are the only group on the periodic table that contains elements in all 3 phases of matter. Fluorine and chlorine are gases. Bromine is a liquid. And iodine is a solid. And this group also has 4 of our 7 diatomic elements in it. If you remember our diatomic elements, obsessed Cleveland Browns fans have no intelligence. Cleveland Browns fans' intelligence are all in this group. So F, fluorine, chlorine, bromine, and iodide are 4 of the 7 iodine diatomic elements, which means they exist as 2 atoms stuck together in their elemental state. The final group we have to talk about on the periodic table are the group 18 elements, and these are called the noble gases. They used to be called the inert gases. They have 8 in their outer shell, group 18. They have 8 valence electrons in their outer shell, except for helium. Helium only has 2. But remember that the first shell is full with 2. These elements are very stable because they all do have a full outer shell of electrons. And they do not react in nature. But there are a few that have been forced to react with oxygen and fluorine in a laboratory. And you can tell which ones have been forced to react because they have oxidation states other than 0. They have charges other than 0 on your reference tables. But I believe they are xenon, krypton, and argon have been forced to react with fluorine and oxygen in a lab. So these middle 3 right here, they've actually been able to make compounds out of those, and some of those are used for refrigeration. So the noble gases are what all the other elements aspire to look like in terms of their outer valence shell of electrons. Okay? That's it for today, everybody. Have a great night, and we'll see you in class tomorrow. Bye-bye.